Let's now take a look at a few examples of total change and average values. You should have first watched the pencast for finding area, because if you remember, the area under a curve is finding the total of all these itsy bitsy little rectangles, and so if we add all those up, what we're doing is finding the total value. So the total value of anything is equal to the integral of the function that you're talking about. So if this represents the number of cars and that you made in a certain year, then the total value for a long period of time, from say the first year to the 10th year, would be have a total value. You would find the integration that would give you your total value. So let's just look at a basic example. Let's say that we had a city with a major mouse problem, and so this function m of t tells us how many mice there are each year, how many new mice, let's say, are produced each year if the city doesn't do anything about the mouse problem. And we want to find the total number of mice from 0 when they first started having the problem for 5 years. So if they let this mouse problem go without any interventions, how many mice are there going to be after 5 years? So we want to add up all of those totals. To do that, we would take the integral from 0 to 5 of d cubed dt. And so that would be t to the 4th over 4 from 0 to 5. And we plug in 5 to the 4th minus 0 to the 4th. And so let's work that out. And we get 625 over 4, which says we should have about 156 and a quarter mice after 5 years total. So you could take how much you're going to have at the end of each year and add it up, or you can integrate and find the total. So we have just over 156 mice at the end of 5 years if we don't get a grasp of that problem. Now we can use this concept to do some decision making. I know that on the TV we always have commercials about put new windows in and it's going to save you money. Well, let's look at an example where you could figure out how much it's going to save you money, or putting a new heat pump in is going to save you money, and that type of thing. So let's take a look at what we have. If I have these two functions where s is my savings and c is my cost, sometimes the graphs will be reversed. So let me show you what I mean. If you graph these two, the first one, the savings looks something like this, so whatever we're talking about here, the savings are recognized right up front, and then the savings drop later. For example, a mortgage in which you have a 3-year balloon, your savings is higher up front than it is at the end. When you graph the cost function here, it looks something like this. So this is my savings, and this is my costs. So here the cost grows as time goes on, whereas the savings shrinks as time goes on. A lot of times this would be flipped over, where the cost is higher first and then the savings comes later, depending on the different situations. And in the case of putting in a new Windows, you have a higher startup cost, and so the graph might be switched. So then the question first is, how many years will we make a profit? Okay, so how many years will we make a profit? Well, at any point that our cost that our savings is more than our cost, we're going to make a profit. And so we're going to continue to make profit all along here. But at this point right here, often known as our break-even point, that is where our cost and our savings are exactly the same, and from that point forward our costs are higher than our savings. So to find out how many years we'll make a profit, we want to set S of x equal to C of x. And if we do that, we get 150 minus x squared equals x squared plus 11/4 x. And now you simply need to solve this for x. So if you'll pause and do that. I chose to graph mine and look for the point of intersection, and when we do, we get x equals 8, and then if you plug that in, you get y equals 86. So at the point of 8 years, if these represent years for our x value, we will experience more savings than cost for the first 8 years, and then after that our cost will overtake our savings. So then the question is, how much am I saving? Because your total savings does not take into the account that you have some cost. So your net savings is after you take your savings and subtract your cost. And if I wanted to know how much am I saving over the first year, let's say for the first year, now I want to add up this area right here from 0 to 1. What is my net savings? So that shaded area is taking care of that. Well, if you think back to the whole idea of area between curves, what we're really doing is top curve minus bottom curve. So we're going to integrate from 0 to 1. The top curve, which is our savings, minus our bottom curve, which is our cost. And we're going to integrate that from 0 to 1 to give us our total cost. So let's clean that up a little bit. We're going to have negative 2x squared minus 11/4 x plus 150. And we're going to integrate that from 0 to 1. So I'm going to do that real quick and come back with the answer, and I encourage you to pause and do that as well. And when I do, I get that we will save $147 and about 96 cents to use whatever mechanism we're using here that's saving us money. We're going to save $147 the first year. Now, what if I wanted to know my total savings for the use of the machine? Now, let's talk about, well, how far are we going to go? Well, we don't know, right? I mean, we would integrate 0 to a, and we'll do our savings minus our cost, and depending on how far you go, you are going to see some things happening. Your total savings should continue to grow from 0 to 8. So 0 to 8, there should be growth in your total savings. But if you go beyond 8, if that number right there is greater than 8, your savings are going to decrease, because now your savings is less than your cost. So you can use that formula. You could run it. What if I ran this forever? You could run this from 0 to infinity and take the limit as it goes to infinity and see what happens to your total savings. What it appears should happen is that you should get a negative answer if you run to infinity, because the costs are skyrocketing. So using that concept of total can help you make a lot of decisions. Let's take a look at average value and see if we can make a connection to something that we've talked about in the past. The whole concept of average values is recognizing that in a curve you're going to have some ups and downs or some changes, but in the end, on average, what did you accomplish? And a speed is a good example. If you're driving a car, you might, in the end, you may have gone 50 miles in 1 hour, but that doesn't mean that you drove 50 miles an hour. So let's say this was our speed for 1 hour. So from 0 to 1, this was our speed. And you know that you went 50 miles in that 1 hour. But sometimes you were less than 50 and sometimes you were over 50. The concept is if I grab the ends of this graph and pulled it, that it would level out somewhere in which, and maybe this needs to dip down a little bit, but the whole idea is that the amount of empty space below, where I just put an X, should equal the amount of empty space above. And I didn't do a very good job there. But I think if you think about in the car, you go 50 miles in the span of an hour, you know that sometimes you went 35, sometimes you went 60, and that balances out. We have used average value before, and remember that average value is just the total divided by the number. And so if we want to find the average value of something, we need the total, which we just learned how to do, and then the number, which would be the b minus a. So this is going to be the integral from a to b, and this is going to be b minus a because it's going to give you how many hours or whatever you're spanning. So let's take an example. F of x equals 3 minus 2x squared, which is not the graph that I have there. I was just showing you something there. And we want to go from 1 to 9. So to find the average value, we're going to integrate from 1 to 9 of 3 minus 2x squared. That's going to give us the total miles we drove, for example. Need my little dx. And how many hours we drove. So we drove 9 minus 1 hours. So we drove 8 hours. So this would be our total on the bottom, 8. And now let's pause and integrate that and find out what our total on top is. And I get that our total is negative 461.3. And that makes sense because our parabola is a downturn parabola and it spends a lot of time below the x-axis. And then if I divide that by 8, I get negative 57.67. So that's not a good example of the driving in the car, but I think you get that concept. This might be an example of money and how much, on average, how much money are we losing a year. We're losing $461 total over 8 years, and that's an average of $57 a year loss that we could have. It could be a little worse, a little better each year, but it's going to average 57. So that's the concept of average value.